Hello, welcome to this webinar. My name is Mike Kramer, and I'm presenting to you today on behalf of Perry Johnson Laboratory Accreditation. I am the Calibration / Inspection Program Manager at PJLA, and appreciate you all logging in this afternoon, wherever you happen to be logged in from. So today we're going to go over two sections of 17025, relatively short sections, sort of combine this webinar into section 7.4, which is handling of test or calibration items, and section 7.11, control of data and information management. As always, this webinar is being recorded. At the conclusion of this webinar, you can retrieve the slides or go back and listen to the recording. Just follow the webinar tab at the PJLA website. There's also an array of past webinar recordings that we have done. Currently, I sure hope everyone can hear me. You all are muted. There is a question tab that should be available to you all. If any question arises as I'm going through this presentation, and please keep the questions regarding our topics today. Type them in there, submit them, and at the conclusion of the presentation, we will go and see what we have there and see if I can provide some clarification or answers to the questions that were submitted. We're going to start with section 7.4, which is the handling of test or calibration items. And sometimes I like to refer to this as the front door to back door. So this is an area where perhaps items come into your lab, calibration items, testing samples. They're received, they're inspected, any deviations are noted. They may have to be stored or prior to be testing or calibrated. Might be some requirements there as far as conditions that need to be met. Then the actual testing and calibration will be undertaken. And then lastly, return of the artifacts or sample or disposal of the sample are all items that this would capture. I feel this section, there's also applicable sections to on-site calibration. I do a lot of calibration assessments, and I see calibrations. Some labs strictly will do calibrations on-site at the customer's location. I've seen quality management systems written where it says this section is not applicable, I believe, and I'll highlight it as we come along. There are you folks that are just doing calibrations away from your fixed facility. So we're going to look at the procedures and, excuse me, not the procedures, the clauses, and then we're going to sort of dissect them a little bit. So I mentioned procedures here. So this is one of the sections in 17025 where, and I highlighted shall, and if you've listened to my webinars before, shall is a requirement. So this is an area where you should have a procedure, something that tells you how it's done, and it should address the applicable areas of transportation, receipt, handling, protection, storage, retention, and disposal or return of test or calibration items. It should include provisions necessary to protect the integrity of the test or calibration and to protect the interest of the laboratory and the customers. Precautions shall be taken to avoid deterioration, contamination, loss, or damage to the items during the handling, transportation, storage / waiting and preparation for testing or calibration. Handling instructions provided with the items shall be followed. So again, this requires a procedure. And somewhere within your quality management system, this is an area that needs to be addressed, and all the applicable requirements here with the associated with the shall should be addressed within your procedure. So we should, it specifies the transportation, receipt, and handling. So in other words, transportation. Perhaps you are a facility that goes out and picks up samples or calibration items, brings them back, or perhaps you just return them, or perhaps your customers do that. So this is addressing, if it's applicable, items that how they're brought into the facility. Receipt. So items come into the facility. Where do they go? Where are they inspected? Perhaps they're logged into the system. Any deviation from what's the contract requests specified and what was actually received should be noted during this process if there are required paperwork. And the handling. So where does it go? It comes into the lab, it goes to the receiving, and then the handling of the calibration or testing items from here, from that point. Protection, storage, retention, and or disposal. So protection. So once the item is in the facility, it should be protected against unauthorized access. Any item that can, any protection against any body or anything that can possibly jeopardize the integrity of the test or calibration items that were submitted. Storage, maybe it's not going to be tested right away or calibrated. Has to go on a shelf somewhere. Maybe there's environmental conditions that need to be met. Maybe there's a period of equilibrium. If you're doing calibration prior to doing the calibration that needs to be maintained. Retention and or disposal. I think this is more in line with testing samples. So once you have a sample, you test it, maybe take a subsample of that sample. Do you maintain or do you keep the sample? If so, how long? If not, how is it disposed? Or after the retention time, how was the sample tested or the remaining sample disposed of? Including all provisions necessary to protect the integrity of the test or calibration items and to protect the interest of the laboratory and the customer. So, i.e. confidentiality. So items are on into your facility, should not be readily available or viewed by unauthorized personnel. That should be controlled. In other words, I like to sort of make a correlation. That's something that perhaps the UPS driver cannot freely walk into the facility unescorted, come into the lab and be able to look at the items that are submitted by your customers. Alrighty, so that takes care of clause 741. 742, the laboratory shall have a system for the unambiguous identification of test or calibration items. The identification shall be retained while the item is under the responsibility of the laboratory. The system shall ensure that items will not be confused physically or when referred to in records or other documents. The system shall, if appropriate, accommodate a subdivision or an item or groups of items and the transfer of items. So you can receive items, test samples, calibration items. Say we have a group of calipers, micrometers there. They all look the same. Your system should have in place how you differentiate one from the other. Same with your testing folks. You have samples come in. They could come in packaged. You could go out and pick them up. You could come in envelopes. Some sort of system to differentiate one from the other. So often, and I do a lot of calibration items, often that's achieved right off the item that's being calibrated. It could be the serial number that's permanent. that would be unique to that particular artifact. For you testing folks, perhaps it's a lot number that could be uniquely identifying the sample that comes in. It could be generated internally right there at the lab. I see this more and more as I'm doing assessments. Things are scanned in, barcodes are used. That has a unique number associated with it. When the individual gets ready to do the tester calibration, they scan the barcode and their computer will pop up the customer's information and all information needed to perform the tester calibration. Could be just something that's handwritten and it's fixed to the sample by some other internally generated identification system. But here, no sticky notes, so it should be permanently attached. So for you testing folks, the test samples must ensure that the ID method is unique and the ID tag or other ID method is not likely to come off, resulting in a misidentification or confusion with other samples. Moving on to the next clause, and we'll look at this. It's kind of a long clause here. We'll dissect it a little bit here. So go ahead and read it. We have a few shalls in here. Upon receipt of the tester calibration items, deviations from specified conditions shall be recorded. When there is doubt about the suitability of an item for tester calibration, or when an item does not conform to the description provided, the laboratory shall consult the customer for further instructions before proceeding and shall record the results of this consultation. I have three shalls right there. That shall record, so that means a record needs to be maintained at that consultation. When the customer requires the item to be tested or calibrated, acknowledging a deviation from specified conditions, the laboratory shall include a disclaimer on the report indicating which results may have been affected by the deviation. So this is an area where we'll go to the next slide. Well, just a couple of key points here before we want to capture from that long clause. So basically, the deviation from specified conditions, whatever they happen to be, shall be recorded, or in other words, a record needs to be made, asking the customer for further instructions. So you're asking the customer, hey, you're outside these specific instructions. What do you want us to do? The record of the results of this consultation and inclusion of a disclaimer. If for whatever reason the customer wants the items tested or calibrated anyway, the lab needs to include a statement with the report. So in other words, test or calibration report that's being produced shall include the deviation within the report. Most of the time, I feel that this is in regards to environmental conditions. And this is one thing, have the on-site calibration services. When you're going on site and or doing testing or calibration, the environment may not be as friendly as it is in the confines of the fixed facility. So deviations from specified conditions shall be recorded. For example, if your procedure, be it an internal procedure or a nationally recognized procedure, have these environmental criteria set in place, temperature range, 68 degrees Fahrenheit, plus or minus 2. Relative humidity is less than 2%. Unit under test must maintain in the laboratory for a minimum of 12 hours prior to calibration to permit thermal stabilization. Within the procedure, it says calibrations are not to be performed if the environmental conditions are outside these allowable limits stated aside. So deviation would be, hey, if you were to do a test or calibration, there was your parameters set forth, and you happen to go in there and it was 65 degrees Fahrenheit, for example, then a consultation needs to be held with the customer as far as proceeding with the test or calibration. The sample, folks, other than environmentally, testing, other than the environmental conditions that need to be met, perhaps you received some untestable or deviation samples which have gotten to the lab. And these would be samples that perhaps the customer provided you, which would be as received. So in other words, you didn't go out and take the sample. You don't have a, you're going to test it as received by the customer. And however, deviations could be due to the sample not being handled correctly during transport or in the way prescribed in the relevant standard, or the lack of essential information for a quality analysis to be undertaken. Consequently, the validity of the reported results may be in jeopardy. So if you open up that sample and it's obviously, hey, there's some sort of effect with the sample, or the sample may have been compromised somehow, and this can include such things as not being preserved adequately, not cooled or acidified. These may or may not be applicable to your area of testing. Have exceeded its maximum preservation time. In the case of microbiological analysis, lack the date and time of the sampling, being natured through heat, light, or humidity, have rotted or suffered microbiologically, or have become cross-contaminated. When you take a sample on behalf of the customer or an external provider, perhaps a sampling organization, and the laboratory cannot be responsible for verifying that the sample was taken in accordance with the relative requirements. Just a statement that the results relate to the item tested, analyzed, as received, which is used by many laboratories, certainly should be enough if there's some obvious concerns once the sample was received and inspected. In such a case, the laboratory shall contact the customer, inform them of the problem, and ask for further instructions. With this, clause 7.1.4, which is a section under review requests, tenders, and contracts, has to be considered in its contents. And that is that clause that I refer to there. Any differences between the request, tenders, and contracts shall be resolved before laboratory activity commences. Each contract shall be acceptable by both the laboratory and the customers. And I think the deviation requested by the customer shall not impact the integrity of the laboratory or the validity of the results. So if you're a 17025 accredited lab, your clients may be considering you as the expert. So we rely on you folks to reach out to them as if there might be some sort of questionable reason for not proceeding with a testing if the sample has been compromised. Now, perhaps the customer wants the sample to be tested anyway. Perhaps you got the sample in and the box was crushed like that. May be a concern. This general finding could be further specified by stating that the sample was supplied in packing which was inappropriate for the relevant analysis, or that the sample date was unknown, or that the sample conditions has deteriorated, are all things that could be, if agreed with the customer, if you and the customer agree to go ahead and proceed and any of these deviations were in place, then these are examples of what should be agreed to and then also documented on the test report. All right, moving on here. 744, when items need to be stored or conditions under specified environmental conditions, these conditions shall be maintained, monitored, and recorded. So if the item is not going to be tested right away, I was once actually involved in moisture, grain moisture testing, and I had to assure that the humidity level was above a certain amount and temperature. in order to not jeopardize the integrity of the moisture content that was brought into the lab. So if needed to be, those environmental criteria, so it can have an effect on the test or calibration outcome. If not done right away, and if they are stored, you need to create a record, shall be maintained and monitored and recorded. So that's an example of a data logger there, which I often see as objective evidence showing that this requirement is being met. Perhaps an alarm would go off if the environmental predefined environmental criteria was to creep outside those predefined limits of acceptance. All right, that covers it for section 7.4, handling of test and calibration items. We're going to switch gears here and go into the second part of this presentation, which is section 7.11, control of data information system. This section, when the standard was revised in 2017, was brought forth, and this has been adapted for the handling of electronic information. As you'll see as we go through these requirements, yes, it does strongly address the handling of electronic information. However, it does allow for hard or paper information to be utilized within the lab as long as certain criteria is being met. So first is access. So the laboratory shall have access to the data and information needed to perform laboratory activities. So again, this is information, the requirements for information management systems. It's not just restricted to computerized laboratory information management system, but to also any kind of system handling information. Calibration should have access to readily available for any sort of information that is needed for them to perform their duties. 7.11.2, the laboratory information management system used for the collection, processing, reporting, storage, and retrieval of data shall be validated for functionality including the proper functioning and interfaces within the laboratory information management system by the laboratory before introduction. Whenever there are changes, including laboratory software configuration or modification to commercial off-the-shelf software, they shall be authorized, documented, and validated before implemented. So here we have a requirement that if you have software, if you wrote your own software, and then sometimes I hear Excel, for example. If you're using Excel itself does not need to be validated. However, if you're using Excel and if you're writing a spreadsheet yourself in order to, particularly if it's looking up data, if it's doing calculations, then you need to validate that. If you are, and we'll have this over here, we have a couple notes here. Again, just another note here stating, and this is right within the standard, that the standard still recognizes paper system right there in the note. Now, commercial off-the-shelf software, by itself, it does not need to be validated. In other words, you go out and you have a reputable vendor that you utilize their software. But if you modify that or tailor it to any specific application, then a record of that validation needs to be performed. Question is, how do you validate? There's many ways to validate. Could do it's doing calculations. Heck, you could just do the calculations longhand, see if you come up with the same result as the software. If you have an example already worked out or one from a nationally recognized publication, I used to write a lot of, back in the day, date myself a little bit here, Lotus and Excel programs. You used to see examples in on this publication, put the same exact data in there, see if I got the same exact answer. So there's various ways to validate. Just have to show that it's been done. If, like I said, if you wrote the software yourself, or if you changed the off-the-shelf software or modified it in any way, then that would need to be validated. 7.11.3, the laboratory information system shall. A lot of these things are in the standard, but things you would want anyway. 7025 need to be protected from unauthorized access. Those folks now, they have permissions granted, password protections, those sorts of things in place. Be safeguarded against tampering and loss of data. The environment that complies with the supplier or laboratory specifications, if there are any, or in the case of non-computerized system, i.e. if you're still maintaining paper copies, that the environment is maintained in such a way that the recorded data would not deteriorate. Be maintained in a manner that ensures the integrity of the data and information. And hey, it's confidentiality there. So if you're maintaining these things within your lab, gotta ensure that the confidentiality of your clients are being maintained. And finally, E, recording system failures and appropriate immediate and corrective actions. So that would address if you had a total, excuse me, a total system crash. E, so should have something, excuse me, in place that would address that. And if it does happen, any corrective action that would be implemented to prevent a reoccurrence of that happening again. Sometimes this information system could be managed off-site, perhaps through an external provider, contract, somebody that you've approved on your approved vendors list, for example. And the laboratory shall ensure that the provider or operator of the system complies with all applicable requirements of this document. So again, first thing that comes to mind is customer confidentiality. So I have to ensure that's being met, data is being protected, being backed up, those sorts of things from the third-party provider. All right. The laboratory shall assure that instruction manuals and reference data relevant to the laboratory information management system are made readily available to personnel. So in other words, if you have a laboratory LIMS system, laboratory information management system, staff should have access to those instructions. Calculations and data transfer shall be checked in an appropriate and systematic manner. So perhaps you're going from paper copy to electronic copy. I often see this with those folks that are doing on-site calibration. Some folks don't allow computers to be brought into their facilities, and data could be handwritten. So this is when you're going from handwritten to electronic. That needs to be checked in a systematic manner as it's going through that transfer. Okay, so this will conclude the presentation for today. Bear with me 1 minute. Let's see if we have any questions here. Right now I do not, so I'll give it a minute and see if I have anybody submit anything. In the meantime, while we're doing that, I just wanted to bring this up, that we do have a presentation coming up on September 12th. And this is going to be presented by Mr. Henry Zombrum at Morehouse Instrument Company. And it's going to It's going to deal with uncertainty, and of course, if you're a calibrator, if you do force, tension, compression, those type of measurements, this would be of utmost interest to you. The title of this presentation is Uncertainty Propagation for Force. However, even if you're not, there may be some items of interest. I've heard Mr. Zombrum speak before. He's very detailed, and even if you're not involved from force calibrations, you may find some things that you can find beneficial and crosswalked over to your application. Please example for validation. I think I gave a few. Like I said, you write your own software. If it's doing calculations, you can well, let me just point out, as an assessor, if I'm assessing your lab and I knew you wrote your own software, I would of course want to see a record of the validation. So you would have to produce a record. As I said, hey, if it's calculations being done, I gave an example, I believe, of where if I had say a standard where I was utilizing, where it had a example worked out, and I says what I just comes to mind because I used to use this often. I used to enter that data into my spreadsheet to see if my result was the same as, in my case, these were typically NIST type documents in IST, or perhaps you could work something out in advance yourself and see if it's calculating out directly. So either one of those two would be acceptable. Of course, I'm sure 17025 aside, you want to assure, if you're writing the software, you want to assure that it's working correctly. So I would assume that, hey, you want to check it out yourself before you actually put it into play into your testing and calibration and the reporting the results for your customer. Whatever you elect to use, just maintain that record. But there are two examples of items, either do it longhand. If it's looking up things, just basically you can go back, check off the block, see if it's looking it out correctly. Just have to maintain a record. What is the extent of comment that needs to be written into the final report of sample deviations? I gave a couple of them in there about well, one in particular about hey, package was damaged, which may impact the result of the test results here. I would say, hey, the standard doesn't go into specific as to how in depth you need to be, but personally, I would think if you felt that it would actually have an impact on the test or calibration results, that should be included into the final statement. This may actually impact the results submitted by this laboratory. I have another question here. It's kind of a specific question. I'm not familiar with COTS, what that is. You use COTS programs such as Access to record readings and then use those readings on your search. Do you need to formal validation? If that's considered off the shelf, then no, you do not need to validate. If this is something you wrote yourself, or if it was something that was off the shelf, then you would need to validate it. If it's just looking up something, it would just be a matter of knowing beforehand what it should be looking up and going back and see if it's looking up the correct item. All right. good questions there. Let's have a lot of interest in validation and how to validate there. Okay, so it looks like that will be the end here. Again, hey, I appreciate everybody signing in. It was my pleasure to present. I hope this value to you folks. Look forward to the next time I do a webinar. Be on the lookout at the PJLA website. And again, keep in mind we have this September 12th webinar, which you can go online at the pjlabs.com. Go to the webinar tab and register for it. Thank you, everybody, and enjoy the rest of your day.